So if you're taking paper notes, or even if you're not, those arrows mean they're parallel, right? The symbol that we write is those two straight lines, but the way we mark it in a picture is the arrows. Congruent is going to be marked different. So congruent, if I have congruent segments, I'm going to mark those with tick marks. And that's part of why we do the constructions. So you kind of get used to marking the pictures. Intersecting lines cross each other. Sometimes they have acute angles, and sometimes they have obtuse angles, and sometimes they have right angles. Remember, perpendicular is always right, and it's marked with that symbol. We gotta know those symbols, okay? Angle bisector is kind of what we're gonna talk about towards the end of the day today. So if an angle is bisected, it has been cut in half. If a segment has been bisected, it has been cut in half. That's where we get those congruent marks, right? So AM is congruent to MB. It's only bisected if they're exactly equal, and that's a really good question. So they have to be equal parts and equal parts. So if it says bisect, that means it's not just parts, it's halves. So you can have a new equation. If you've got two pieces and you know they're identical, then you can set those two things equal to each other. Any other questions? That was a great one. Okay, let's look down at slide 7 and see true or false. Determine if the following statements are true or false. If the statement is false, explain why. So if two lines intersect, then the two lines are perpendicular. Is that true? False. Why is it false? Right. They could just randomly intersect where I have two acute angles. So here, those two acute angles are going to equal each other. Acute equals acute. And we've got two obtuse angles over here. And the obtuse angle equals the obtuse angle. Obtuse equals obtuse, right? If we've got perpendicular lines, then we've got very specific 90-degree angles, right? And notice that all of those angles are 90 degrees. So if you have one 90-degree angle, you have four 90-degree angles. Okay. Again, I know I'm going quickly, so stop me, ask questions. On slide 8, the segment addition postulate also has a video. So if in those purple warm-up slides, you were still a little bit confused because we went from a very easy example to kind of a medium example to kind of a tough example, please watch this video. It'll go through all of these examples one at a time, okay? But basically what I want you to see here is this part, AB, plus this part, BC, equals the total of the entire thing. Again, if I have 25 cents and I add 75 cents to it, I have $1, right? If I go 2 miles from my house to the rec, and then I go 3 more miles to my friend's house, that's 2 miles plus 3 miles. I've gone 5 miles total. The part plus the part equals the total. So the part plus the part equals the total. If I'm looking for one of those parts, then I can just put in a variable. If you're looking for PQ, you just make it a variable. And then it's the same thing. The part plus the part equals the total. Okay. So in those purple slides, if you're still a little bit confused, or if you were trying to do Tuesday's work and you were frustrated with the math space or with the IXL, this is a good place to come get some help. And if my videos are too confusing, you can look at one that's just specific to segment addition right here. I'd have you snap twice if you guys were unmuted, but I don't know that I'd hear you if you snapped. So let's talk about midpoint. I think that's next. And I know these kind of went out of order, which is, again, maybe part of the confusion. But we've talked about midpoint formula, right? If you're still a little confused, remember midpoint is average. We're going to add the x's, divide by 2, add the y's, divide by 2, and we're going to end up with an ordered pair. Please, please, please graph it, right? Graph it, open up a Desmo, sketch a graph, do whatever you need to do to make sure that it makes sense. If I give you 2 endpoints and you plot them in Desmos and then you do the calculation and your dot is way over here in the second quadrant, you're gonna be like, oh, I did something crazy, right? Maybe I subtracted instead of adding because I was thinking distance formula, or I was thinking slope, or I did the y's first. Like what? There's a whole ton of different things that can go wrong here. But if you plot your starting point and you plot your ending point and you plot the middle point and you go back and make sure it's asking for a middle point, then you're going to be golden. Okay. Questions, comments, concerns, worries? Take a breath. Okay. Slide 10. How does slide 10 change from slide 9? What's the different question? Yeah, so here we're finding the other endpoint. And guys, this is where close reading and critical reading come in. You're going to kind of scan this. You're going to see 2 points. You're going to see the word midpoint, and you're going to do x plus x divided by 2 and y plus y divided by 2. And sadly, you're going to do all the math correct, and you're going to get a wrong answer because you answered the wrong question. So here, if you haven't watched these notes yet, the key part to this is the middle point needs to go in the middle. M is the midpoint of AB, and M is 510. So 510 has to go in the middle. The endpoints have to go on the ends. And then you're just going to follow the pattern, right? So let me zoom in a little bit so we can see this a little more easily. I put the middle point in the middle, and I follow the pattern. 7 plus 3 is 10, and 10 plus 3 is 13, right? And same thing for the other side. So what numbers would go in here? M is the midpoint of AB. Find the coordinates of B if A is this and M is this. Well, A is one of my endpoints. So I've got A here and B here, and M has to go in the middle. So we do -5 and 2, and then -1 and 8. So on the number line from -5 to -1, I'm going up. I'm getting bigger, right? Or less negative. So -5 plus 4 is -1. So -1 plus 4 is 3. So this answer is going to be 3. And then on the other side, if I go from 2 to 8, I'm also getting bigger. If I had $2 yesterday and I have $8 today, that must mean I earned $6. So 8 plus 6 is going to be 14. Again, I'm going to pause for questions. Anybody got questions? I'm looking at the chat. You guys are conspicuously quiet.
No, I don't think we have any questions.
All right, Dalton, I'm going to trust you. Here on slide 11, what mistake was made? What's wrong here?
You need to switch the first 2 coordinates with the second 2 coordinates.
You absolutely do. That middle point has to go in the middle. So -2 and 9 and 4 and 7. I need an end point, a middle point, and then I can find the other end point. Okay. What went wrong in this one? you're not sure, you can draw a picture. So X, Y, and Z are collinear, and Z is the midpoint. So X, Y, and Z goes in the middle. That means ZX and ZY are going to be congruent. So I have X and I have Z. Is this how I do it? It is not. Z is the midpoint, so Z has to go here, 7, -7. If Z is the midpoint, the middle point has to go in the middle, right? If I'm finding the midpoint of ZX, what I'm actually finding in this is this point right here. That's going to be 1, -2. And I want to know what Y is, so we're not in the same spot. -5, 3. Okay. Distance and Pythagorean theorem. We've taken a long time here. Do we have questions about distance and Pythagorean theorem? If you have problems here, come to office hours today and we'll talk about it. But there's a video right here. You've got the vertical distance. You can just count the jumps, literally 1, 2, 3, 4 onto 8, and the horizontal 1, 2, 3 onto 6. If you need to do a diagonal, this is what you need to do, ladies and gentlemen. Maybe. You can make a right triangle by doing the horizontal piece here and then a vertical piece here. This is your a squared, b squared, c squared of a right triangle, where the right angle is here and the hypotenuse is opposite it. Remember, your hypotenuse is c, and these are both legs, right? So one's going to be vertical and one's going to be horizontal. Well, this x minus x is this distance. You just take those two x values, -4 minus 2, that distance is 6. So the a and the x minus x are the same thing. And the b and the y minus y are going to be the same thing. So from -4 to +5, this distance is 9. Y minus y is going to be 9. And then you end up with 6 squared plus 9 squared, and you take the square root to get the diagonal. Again, if that was too fast, watch the video, guys. This was Tuesday's work, and I realized that Tuesday was a lot, but it is important to try to keep up. I will be in office hours today if you need me. Then we've got our distance formula. So this does Pythagorean theorem, another video if you need it. And then 14 is distance formula that we've already talked about. Okay, x minus x squared plus y minus y squared. The page I really wanted to get to today, and we don't have a ton of time here, is these bisectors. So we've already kind of talked about bisectors needing to be exactly equal, right? So in these notes, you'll see the segments are cut in half. So here we can modify our part plus our part to say the half plus the half equals the total, or the half equals the half, right? So in your paper notes, under angle bisectors or segment bisectors, right, the half equals the half. So all we did was we take the left side, that 3x plus 5, and we set it equal to the 5x minus 19. And then you solve it and solve for x. With angles, it's going to be exactly the same thing. So this part plus this part is going to equal the total, and the half is going to equal the half. Okay, so this half is going to equal this half. Keep this open for a minute. Go over to class link. Everybody go over to class link and open up IXL. You can't see my IXL icon down there because of my sharing toolbar, but hopefully you can see it. And if you need to split your screen, do that. I want everybody to go to Geometry C5, C like cat 5. And if you're tempted to just watch me do it and not do it yourself, please resist the temptation. Minimize the zoom if you need to, so all you're hearing is me. But let's go up to learning, or you can search up here in the top. You want to go to geometry. Maybe. And then go to C5. C like cat. I think it's the first C skill I've asked you to do. So I want to talk about angle bisectors. The first ones are pretty easy, but right around 40, it gets kind of weird. So this is your time to get this done in class. We can get to 80% right here and now before we have to leave, as long as we work quickly. You're going to have to read these, okay? If an angle measuring 16 degrees is bisected, that means this whole angle is 16 degrees. So if it's bisected to form two new angles, I cut it in half. This piece is 8 and this piece is 8. Don't put the decimal in there, they'll count it wrong. If an angle is bisected to form two new angles, 20 degrees and 20 degrees, this half is 20, this half is 20. So the whole original angle is 40, twice that big. If you're given the total, you're going to divide it in half. If you're given the two halves, you're going to multiply them by 2 or add them together. After bisecting an angle, Devin has two new angles, 27 and 27. So here the half plus the half equals the total. So that's mine's going to be 54. Hopefully you're doing yours at the same time. I have a half and a half, so I'm going to add them together to make a total. Here I've got a half and a half, so I'm going to add them together. See how it starts off so easy, and then it gets a little tricky. So hopefully I've given you enough time to get up to about 40. What I want you to notice here is this angle V has been bisected. I've got WVT is congruent to UVT. Those are congruent. That means if I draw a straight line out to that side that's opposite it, and a straight line out here, those are going to be the same length. Okay, so if you have a bisected angle and you've got right triangles here, then these opposite sides are exactly the same. And there's going to be a handful that are kind of going to look like this. If this gets frustrating and you're not sure how to do it, guys, this is another thing. If you find yourself working and working and working on IXL and it's only giving you frustration, stop. Okay, there is no reason for this to cause you stress and frustration. I want you to do as much as you can do within a reasonable amount of time. Also, don't spend 4 hours on geometry. So TU and TW are congruent. We can make those congruent marks. They're also both 58. That means this angle and this angle are going to be the same because the 58s are the same. Those angles are the same. So TVW is 38. What is UVW? So from U to V to W is that whole thing. So if the right side is 38, then the left side is 38, and the whole thing is 38 times 2, which is 76, I think. Does that make sense? If this piece and this piece are congruent, then the angles opposite them are congruent. That means this half plus this half equals the total. So 38 plus 38 should be 76. Same thing here. If I've got 50 and 50, and I know this is 40, what's this piece going to be? Should also be 40. If these two angles are congruent, that's what those angle arcs mean. Then if this is 45, then this is 45. Can you use the angle bisector theorem to solve for GH? Yeah, it's 45. Questions on these guys? All right. You have pretty much just done all of today's stuff with the exception of the math space. I'd like to give another little public service announcement. Math space is frustrating. I know math space is frustrating. Okay. Try them, do the best you can do. And if you're getting frustrated, stop. These investigations and constructions are super important. They are so good for your understanding, but if they are frustrating, stop. The one thing that I 100% need you guys to do today is this quiz right here. Okay. This quiz must be done before we come to class on Tuesday of next week. Remember, I'll be out again tomorrow. This is my last meeting of the week. Okay. So we've already done the bisector. We've already done the C5. In this video up here is more video about C5, and I will post another one. There should be a math space help video here, and then your angle basics. It's going to be a little bit different what's in this angle basics lesson. It should be crazy easy. Okay, but please, 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 if you don't do anything else, do that green puzzle piece. All right, I'm going to stop sharing. If you are good to go, you are good to go. And if you have questions or concerns, come see me during office hours.
Okay.
See you, Dalton.